Welcome back. This is Ramans and it's me, Priska Joseph. Dear student, we already discussed our exercise 1.1 and we have completed all the questions from that exercise. So in this class, we are discussing exercise number 1.2. Okay, so before entering into our session, if you're watching my channel, please subscribe it and don't forget to hit the bell icon for the notification. Your comments are valuable for me, so please comment below. So don't waste time. Let us start our question. So the first one is prove that root 5 is irrational. Okay, we have to prove that root 5 is an irrational number. Okay, so dear students, actually this is a very important question from this chapter. This is a frequently asked PYQ. You have to follow the same steps for all such questions. If we are asked by root 5, root 2, root 7, anything, we have to follow the same steps. Okay, so listen carefully. So what to do is, root 5 is irrational. In this question, they already states that root 5 is irrational. So we have to take the controversial statement. What is the controversial statement? That is, let root 5 be a rational number. Okay, so this is the controversial statement. And first step of such questions is let root 5 or the number should be considered as the rational number or the controversial statement. Okay, so let root 5 be a rational number. Okay, so what is next? Okay, so what is rational number actually? Any number which can be expressed in the form of P by Q are said to be rational number. Any number which can be represented in the form of P by Q, then it is said to be a rational number. Okay, so we can write root 5 is equal to A upon B. And one more thing is there, where A and B are co-primes. Okay, then what is co-primes? Any number which has 1 as the common factor is said to be co-primes. So A and B are considered as co-primes. Okay. Now on cross multiplication, what we get? Root 5B is equal to A. The next step, squaring both sides. Okay. What we get? What is root 5 square? Root 5 square is equal to 5 itself. Okay. So 5B square is B square, which is equal to A square. Did you get me? Okay, so 5B square is equal to A square. Now, if I am writing here a statement, after that we will explain it. Okay, so if 5 is divisible by A square, then 5 is also divisible by 5. Okay, let me show. If 4 is divisible in 8 square, then 4 is also divisible in 8. Okay, in the same way we have to write like this, that is, if 5 is divisible in A square, then 5 is also divisible in 5. Sorry, 5 is also divisible in A. Okay, did you get me? Then now this relation should be marked as 1, equation number 1. Similarly, let us consider another number, that is, let C is an integer. Okay, let C be any integer, then we have to write A is equal to 5C. Okay, so let C be any integer, then A is equal to 5C. Then squaring both sides, what we get? A square is equal to 5 square is 25 and C square is C square itself. Okay, A square is equal to 25 C square. Okay, and from equation 1, we have to write, I'm writing here, that is 5B square is equal to 25 C square. Okay, It's clear? From equation 1, here 5b square is equal to a square, and substitute this value of a square in this equation. Let us consider this as equation number 2. Then 5b square is equal to 25c square. Okay, is it clear? Then on cancellation, we get b square is equal to 5c square. Okay, and this is equation number 3. Okay, then as we stated earlier, if 5 is divisible in b square, then 5 is also divisible in b square, then 5 is also divisible in b. Okay. So from these two statements, it is clear that 5 is a common factor. These two statements, we can conclude that 5 is a common factor between a and b. So, which is contradicts that a and b are co-primes. Okay, so 5 is a common between 5 and b, which is a contradiction statement for this, that is a and b are co-primes, which means this assumption was actually wrong. That means root 5 considered as a irrational number. Okay, is it clear? So this is the answer. Hope it is clear for you. There are some more examples in this exercise problem. So let's solve the next question. So dear student, let's solve question number 2 from the exercise 1.2. So the question is, prove that 3 plus 2 root 5 is a irrational number. Okay, prove that 3 plus 2 root 5. This is the number. It should be an irrational number. So this is the question. So as we stated earlier, we have to take the contradiction statement, which is that is, let us assume that 3 plus 2 root 5 is a rational number. Okay, so this is our assumption, and what to do? That is 3 plus 2 root 5 is equal to a upon b. Okay, the same step. Okay, so 3 plus 2 root 5 is equal to a upon b, where a and b are co-primes. Okay, co-primes. Now let's cross multiply these two numbers. Then and 2 root 5 is equal to a upon b minus 3. Only root 5 should be there in the LHS side. So what to do? 2 root 5 is equal to, first of all, we have to rearrange this equation. That is a minus 3b upon b. Next, root 5 is equal to a minus 3b divided b. That is 2b here. Okay. On cross multiplication, we can write root 5 is equal to a minus 3b upon 2b. And next step, what is next? We already discussed root 5 is a irrational number. We have already proved the statement that root 5 is an irrational number in the previous question. So we have to write down all these steps. Okay. So root 5 is a irrational number, so that an irrational number should not be equal an rational number. A rational number. Okay, so we can conclude that 3 plus 2 root 5 is a irrational number. Okay, since rule 5 is an irrational number and RHS should also be an irrational number. Okay, so listen carefully. You have to write down all the steps of the previous one. That is rule 5 is an irrational number. Okay, did you get me? So this is the answer. Hope it is clear for you. If you have any doubt, please ask me in the comment section. In this class, we are discussing the last question from the exercise 1.2. Okay, so dear students, if you are interested in my videos, please subscribe it and don't forget to hit the bell icon for the notifications. Your comments are valuable for me, so please comment below. Now, let us solve the question. That is, the first one, prove that the following are irrationals. There are three sub-questions, 1 upon root 2, 7 root 5, 6 plus root 2. Okay, so the first one is, let us solve the first one, that is 1 upon root 2. As usual, we have to assume that 1 upon root 2 is a rational number. Okay. Then 1 upon root 2 is equal to a by b, where a and b are co-primes. Then root 2 is equal to b upon a. What is that? The reciprocal of 1 upon root 2 is root 2 upon 1 or root 2, which is equal to, here also we take the reciprocal, which is b upon a. Okay, so we already learned that root 2 is a irrational number. Okay, write down all those steps that we have done in the first question. Okay, so it is clear that root 2 is a irrational number, and an irrational number does not equal to rational number. So we can conclude that 1 upon root 2 is a rational number. Okay, is it clear? Now let's solve the second question, that is 7 root 5. Same steps are here. That is, assume 7 root 5 is a rational number. Then 7 upon root 5 is equal to a upon b. Then root 5 is equal to a upon 7b. Here root 5 is an irrational number. Then an irrational number never is equal to, an irrational number never should be equal to a rational number. So our assumption was wrong. Then root 5, so that 7 root 5 is a irrational number. Okay. Okay. Clear? And your part, you have to write down all the steps that we have to prove root 5 is a irrational number. Okay, and after that we have to you have to write down this statement, that is, an irrational number never should be equal to a rational number. So our assumption was wrong. Then this number should be an irrational number. Okay, so that's it. Now question number 3, which is 6 plus root 2. As usual, this should be a rational number. Our assumption is this is a rational number. Then 6 plus root 2 is equal to a upon b. Root 2 is equal to a upon b minus 6. Then root 2 is equal to, on cross multiplication, we get a minus 6b upon b. Then root 2, we know that root 2 is a rational number. Is an irrational number. So an irrational number never should be equal to a rational number. So our assumption was wrong. And finally, we can conclude that 6 plus root 2 is a irrational number. Okay, it's clear. So dear students, we complete our chapter 1 real numbers very well. Okay, hope it is clear for you. If you have any doubt from this chapter, you have to comment below. Okay, so that's all for the day. Thank you. Have a nice day. Remember one thing, practice each and every question well. Okay, thank you.